Okay, so this is the last lecture. I did notice a bug in yesterday's lecture, which is that it says number 19, but it's really number 20. The YouTube video is correct. The slides are now correct. This is the beauty of having all this stuff online. You can fix things up even after the fact. So this is actually lecture number 21. I will have the YouTube video up by 7 o'clock today, if anybody else needs to watch it. All right, so let's just dive in, because this is sort of, oh, I forgot, there is one other thing for tomorrow, which is at the very beginning of class, I will give probably my own 5-minute sort of overview summary of the entire class. Okay, so I'm going to give you sort of Dan's perspective on the class. I just talked to Michael Boland, and we were sort of going over the class, and I said, "You guys are all great." He's very happy with the class. I'm happy with the class, so it's all good. But I'll give you a little sort of summary of what I thought the whole class was about, because it's interesting that I started off with this vision of what it was going to be, and what it actually turned into was something better. It was even better than that. So I hope you feel the same way. Okay, so let's talk about location and mobility. So these are this is 3 papers. Where the gestalt is, it's all about how people share location information. How many of you have ever used Foursquare? Anybody? Okay, you're kind of a retro guy. Yeah. So one of the papers is about Foursquare today, and I realized almost nobody had ever used it. I used it briefly, but it's in the past. But now we have Twitter, we have Facebook, we have all the other things. So we'll talk about how people share location, or as we'll see in the last paper, they kind of don't. Okay, so this is really sort of the location-based version of social network analysis, which is sort of fun. So in particular, this kind of goes back. Remember the very first lectures, we were talking about sort of social network analysis in the way distant past, and we saw that YouTube video by Bill White, where all the people were wandering around in the plaza, in the Platz, right? Remember that? We're coming right back to that, because this first paper by Justin Cranshaw is really about using location data from all the social media to reanalyze neighborhoods. Because remember what happened, that original work came out of the sort of growing analysis of neighborhoods, analysis of shared community space, and now we've got a new way to study this. Because doing it back then was a major, major pain. What we would do, what Bill White did, is he would send out flocks of graduate students with clipboards. Remember the clipboard thing? They would go out and they'd talk to people and they'd time them, how long it took them to walk across the plaza, all this stuff, right? Now we can do a lot of this automatically in massive, massive numbers, and it's changed this kind of science in an interesting way. So this first paper is about how do you do new kind of neighborhood analysis using geolocated tweet information and so on. So this paper is called Livehoods. And what is a livehood? It's this construction they have where they reanalyze how people are existing in a neighborhood. So it's basically the idea that you can analyze the structure of a city and what its people are doing by looking at this geo-coded social media. They do it for Pittsburgh, but there's no reason to believe it wouldn't work anywhere else. It would work here, it would work whatever. But they work for this particular example. In Pittsburgh, kind of smack in the middle of the United States, an old industrial town that has been, past, say, 20 years, it's become kind of a tech center. So Carnegie Mellon University is there, Pittsburgh Glass Center is there, a bunch of technology companies have moved in. But it's still going through this crisis, this big change, so it's an interesting example. They then validate it with these nice qualitative interviews. And so this is in many ways a really nice paper. They have this crazy idea, they magnify it by using massive amounts of quantitative data, and then they validate it by going and talking with people who live there. Is it really true that what our analysis shows is correct? So it's a very nicely done paper. So their hypothesis is, and I quote here, the character of an urban area is defined not by the types of places found there, but also by the people who choose to make that place a part of their daily routine. The reason they say this is that a lot of the old work in this area was going around and counting the kinds of places. How many bars per block were there? How many vacant buildings were there per block? How many churches were there per block? How many? So that was the old way of doing things. Now, with this geolocated social media, we can see what people, how they define themselves and where they say they're going, and we have very fine-grained real data as opposed to this externalized data which we've got by going around and counting things. So Foursquare, for people who didn't use it, was basically a system where you would go to some place. You go to a restaurant, or you go to a pub, or you go wherever, and you would check in. You know how Facebook allows you to check into a place? Same idea. Foursquare did it first. So it was a big deal because you could become what was called the mayor of a place by having the most check-ins, right? And so you could vie with your friends, and it wouldn't let you check in more than once a day. But there were some places, some coffee shops, for example, near where I lived, where people would go there every morning, check in, and leave, just so they could be now nominated the mayor, because there was a leaderboard. You could see how many people had checked in, and I could see that Marcus had checked in, yesterday or 4 hours ago or something. So it was kind of an early effort to sort of do this social networking stuff. So what they do in their analysis is they get this data from these Foursquare check-ins, and they cluster by geographic proximity, which is not a surprise, but also by social proximity. That's the new and interesting part here. Social proximity is what kind of people are going to what kind of places. You'll see how we get that in a second. When they do this clustering, you see it on the map, and that's called a livehood. This is where people actually live. So it's like a neighborhood, but it's defined by actual behavior. So here's an overview of the paper, right? They go and they collect the Foursquare data. They create this clustering algorithm. Sidebar comment. They didn't really make it up. They just borrowed one from the literature, which is fine. Okay, but they spend a page and a half talking about the clustering algorithm, and it's just off the shelf. But the third part here is kind of nice. They went and validated it. They went and talked to people who lived in the neighborhood and said, is this right? You'll see in a second that sometimes the results of the livehood do not line up with the official neighborhood boundaries. And that was a surprise. So if you remember back, now this is prehistory for you guys, but back in the old days, in the 90s, people were investigating the same kind of thing. Again, doing this sort of manual counting and stuff. But remember this guy, Stanley Milgram? Lecture 2 or 3, way back early in the course. Yeah, he came back. This guy, he's one of this. He did the prison. The shocking experiment, and he did a lot of early social network work. So he was the guy with the letters. Remember that? Yeah. In 1977, which is roughly 15 years after the letter experiment, he did groundbreaking work in this area about defining what a social interactions, how they created. What he called the local character. So you know how, let's say, over by Oerlikon, right? There's this, it's kind of not a neighborhood, but there are little pieces of it that are neighborhoods, right? And especially this part over here, over towards, say, SRF, which has been going through a big change over the past, say, decade. The neighborhoods that were there and the industrial plants that were there are changing. And so he was starting to do that work back then. And remember him? Mr. Big, he was the cool YouTube video guy who talked about people walking around and being on the edges of the sidewalks and stuff. That was him. So in 2001, he was still writing, and he points out, man, this is painful to do. But that was then. This is now. Okay, so they have a decent data set size. So they had 18 million check-ins in 6 months, 2011. I know, this is a long time ago. This is like 6 years ago. But they then took from 18 million check-ins, that was worldwide, they boiled it down just to Pittsburgh, because they know the geocode, they know the lat long for each one of these things. And then they just figured out we're going to boil it down to 3,800 users at 5,300 places. So this is 5,000 different places in Pittsburgh. It's a lot, actually. So it's 5,000 coffee houses, restaurants, bars, everything, sports arenas, everything. Okay, so now the data they have looks like this. So they took all these check-ins and they extracted it and turned it into a CSV file, which has a universal identifier. So it's a code. It's, you are number 49532. You are number 49535. Right? So you have a unique identifier. The time of day, 24-hour clock, latitude and longitude, place name category. Place name would be, I don't know, Metzger Baccarat or whatever, right? That place over there. It'd be a name like that. But then the category is the type of the place. It's a restaurant. It's a cheap dive. It's a cheap bar, right? It's a place to go dancing. It's a whatever. So those are defined by Foursquare. And they actually got this whole hierarchy that looks like this. So, for example, one place is a college bookstore, which is a type of something within the college and university. And they have hundreds of these categories. So they actually now can start to do, that's what they mean by social proximity. So 5 bookstores in a row, you've got an interesting cluster. 5 bars in a row, you've got an interesting cluster, right? You rarely see bar, church, bar, church, bar, church, right? That's not a social cluster. That doesn't happen. But you might see bar, bookstore, restaurant, cheap restaurant, right? And these are all labeled categorical types of places. Okay? So this is just out of the paper. You can read this if you're really into the algorithm. I'm not going to go over it. This is not an algorithm class. Basically what it does is that you bring in the data set and you start to try to minimize the total distances between things of the same category. And you're doing this across category and across space. You're minimizing 2 dimensions. So in order to do this, they actually project it out into a high-dimensional space, which is a standard trick of clustering. And then they try to find, imagine this, right? This is my hand-wavy explanation of this algorithm. You take this data, we have 4 dimensions, plus this categorical stuff, so we have much higher dimensional data points. And you try to find hyperplanes through that space that say, oh, this is a lump that minimizes total distance between those points of the same kind. Here's another hyperplane, goes like that cuts this space. And that's what this is trying to do. And there's the fancy language for doing it. Multivariate statistics, they're doing this by reducing the clustering in multiple dimensions. Fine. If you want to go do that, be my guest. The point is that they generate these very nice clusters. And you can sort of see it here. So the way to look at these maps, let's look at this first one on the left, okay? This is a neighborhood called Shadyside. This is another neighborhood called East Liberty. Well, those names have been traditional. They've been there for a long time. The boundary here in black, oops, goes over there, and it comes back. That's the boundary defined by the city. So the city government says, if you live in Shadyside, you live in here. If you live in East Liberty, you live in this block up here, and so on and so on. Okay? Those grew out of traditional city-village boundaries. So you know how different sections of Zurich are kind of funny shape. Same thing, same idea. But what they do is they now run this clustering algorithm, and they discover these clusters of socially proximal elements. That's what all these dots are. And here's the red one. So that we're just going to call it LH1 for this red one, LH2 for this blue one, and so on, right? So this is what the algorithm discovers. So what it's saying is that, well, here, this whole thing here is called Lawrenceville. So if you ask somebody in Pittsburgh, where's Lawrenceville? Let's say, right there. I know exactly where it is. Well, it's also been subdivided into upper, central, and lower. But there's another community here called Polish Hill. But the livelihood, that's what LH stands for, livelihood 3 says it's all of Polish Hill and most of Upper Lawrence, and oh, by the way, the part of this little island over here. Okay? So unfortunately, there's a bridge under there you can't see, so people actually don't have to swim. But there's something interesting going on, because these discovered neighborhoods that we see in the data don't reflect the underlying geographic official boundaries. You probably know about neighborhoods that are like this, right? You can think of ones at your home where you live. And then it's interesting to look at. Here's a bunch of other places. Those are not connected to anything because they don't form a coherent cluster. They might cluster with something over here, but these are the ones we're going to focus on. But this is what livelihoods are. So the first finding, and this was a little bit of a surprise, is that, like I said, the livelihoods and the official boundaries really don't line up. So I don't know what this little neighborhood is called, but it doesn't have its own identity. It's part of two different groups. Okay. Now here's the neat part. What they did, they ran this algorithm, found these maps, and said, I wonder what people think. They went and did 27 interviews and said, hey, look at this map. This makes sense to you. You live there. You know what the ground truth is, right? And they say, yeah. And then they get their stories. Why does this make sense to you? And in my interview with you, we'd say, well, you know, this area has been changing over the past several years. It's become more hippie, granola-eating people, right? And this part's becoming more very high-end tech people. So, for example, in San Francisco, there's an area called South of Market. There's a big street, Market Street. South of Market is where Uber is and Amazon is and all the tech companies in the world are all south of Market. And that's a livelihood area now. It had a coherent identity. Previously, it was, shall we say, economically depressed. You know, it was basically not a nice place to go at night. But it's changed over. So when they interviewed these people, they said, why does this map make more sense than the official boundaries? And they said three different things. They said that things split. So that's when a neighborhood is split into these different livelihoods, okay? Because this group now belongs more together than that one. In particular, one of the ways this split happens is when you get spillover, or what's called spilled. This is when it goes over the next border. So, for example, where was it? I think it was in Pittsburgh. I think it was here. There was let me just go back to this bit. I'm going to make up this one story, but this is what happens. If you get a junction right here, where two places are, say this is lower class and this is upper class, and you get, for example, a very high-end grocery goes in here, this will start to move that way. That's the spillover effect. It starts to colonize that area, starts to move into it. So this is not surprise. It's sort of a surprise, though. We can look at Foursquare check-ins and see this happening in real time. And then, of course, the last one is, oh yeah, that's the same. The livelihood and the boundary is the same. So what's going on is that when you get these splits, it's you having different demographic groups, either by economic class or by ethnicity or by occupation. So these classic demographic changes happen and cause these splits. And of course, the transitions are when things are happening. Either it's going up, gentrifying, or going down. And the corresponding one, this last one, where the live cluster and the geographic political boundary align, that's usually because that official boundary has some really important thing. So for example, the airport, right, that is actually defined as a neighborhood. And there, you know, for example, at San Francisco Airport, where I fly in and out of, there's actually a zip code just for that airport. So that's an official boundary, is that line defining that. That's an extreme case, but you can see the same kind of thing happening. So now, remember, when you read these papers, one of the things you should always be asking yourself is, when does this not work? When does it not apply? First off, Foursquare users tend to be in your age group, 20 to 30, reasonably affluent, very techy. Right? The fact that you're here indicates that you're part of this group. Right? So they tend to be very tech forward. They adopt the new thing. And conversely, they drop it when it gets stale or old. That's why none of you use Foursquare now, right? And they're also very socially aware, and they tend to use social media extensively. So in Foursquare days, lots of people not only used Foursquare, but did a lot of check-ins as well. So it's a heavily biased sample, but the interviews, they also interviewed 7 city planners for Pittsburgh. And they all said, that's really good. That data is better than what we have on our maps. So I don't know if Pittsburgh is doing this. I know Mountain View, where Google is, does this a lot now. They have a giant GIS system, graphic information system, for the whole city. And they're now taking into account pieces of data just like this. So I don't know that there's a causal connection there, but it's definitely kind of at the forefront of technology causing cities to take this kind of data into account. Okay, so that was the use of social data, social geolocated data, as a way to understand urban geography. Let's switch it and think about that data in use for a particular purpose. And so these folks, who are all at Yahoo Labs in Barcelona, I didn't know Yahoo Labs had a Barcelona office, but hey, excellent. I don't know if it's still there or not, because Yahoo is, complicated. But at any rate, this was from a couple years ago, and they said, hey, look, if we've got all this social data, couldn't we use it to make my life better? For example, when you go to Google Maps, it gives you a route, which is always the shortest route, maybe the fastest route, or maybe some combination thereof. Couldn't I give you a route that was pretty or peaceful or some other property? And so they said, well, what would we have to do in order to provide you that information? Think about it. How would you do that? Paper's very clever, right? So the objective here is to create these routes that satisfy not just the time and distance objective functions, but to introduce other objective functions like the beauty of the place, the quietness of the place, the peacefulness of the place. And the first thing you should think about is, how do I quantify beauty? Because if we're going to put it into an objective function to allow the route planner to work, at some point you have to say, you are a 0.8, you are a 0.7, you are a 0.95, or whatever, right? You have to quantify that definition so you can use it algorithmically. How do you do that? And that's what I think was very clever about this. So that what they want to do that is, well, here's the base case, right? So this is a Google map from where I was working. This is the Google office over in the Harlemon site. And this is where we are now. And so I said, how do I get to school? And it gives me a bunch of options, but if I take the tram, it says do this, do this, do this, do this, right? It's fine. It's minimizing total time. There is currently no way to say, this part, I don't want to go there. I want to go through a beautiful route, right? So up here, what I want is, not just by car or by tram or by walking or by whatever, or by airplane. I guess I could fly. I want the beauty button, right? Show me the most beautiful path. And if you think about it, you know that there are better and worse ways to go, right? So for example, in parts of Los Angeles, where I grew up, there are more and less dangerous ways to go. There are certain parts of the city you don't want to go in there, especially after dark, right? Maybe it's true in Zurich. I assume Zurich is all a lovely place. But, you know what I mean, right? You would love to be able to incorporate these factors. So what do we do? So this paper is really, what they do is they first break down the problem. They're not going to recreate Google Maps. So they make a version of it, which is this node graph diagram. So they're going to create a graph where each node is a place, and it's got information about how pleasant they are. Now, okay, fine. How are you going to define pleasant? We'll get to that. Right? They then quantitatively validated how pleasing these paths were, which is kind of neat. And they generalized the method by, this is probably the neatest result, by predicting the beauty scores from Flickr data. So Flickr, the online image sharing site. Yeah, that means somebody wrote a piece of code that says, given this Flickr image, rank it beauty, 0.9 to 0.1, right? Go ahead, write that code for me. All right. Anyway, I'll show you how they did it, because it's very clever. So what they did first is to build a graph. Again, this is basically to simulate having Google Maps. So what they did is they took London, here's London, they broke it up into a 22 by 22 grid, gives you 532 blocks, right? Each about 200 meters on the side, so grid, right? They then wanted to measure the beautiness, the quietness, and happiness of those locations by crowdsourcing street views. Yeah, that's what I thought. Really? Yeah, this is what they did. They set up a website called urbangems.org, which is still active, by the way. You can still go there. And what they do is they have these 532 cells, and they grab street view images from 2 different places randomly. So given the street view, which is, I don't know, say 200 kilometers of road, they go to the Street View API and grab these images and put them up side by side and then say, which place do you find more beautiful? So they punted, right? They appealed to you, the human, to rate these places. And what you end up doing is, it's like, it's really interesting because it's just like a machine learning component, except it's human learning component that's being expressed as preferences. So I would say, I prefer that one to that one. If you press me on it, I would say that has more trees, looks quieter. But on the other hand, if I'm in a social mood, I might say I like that one. But what they did is they ran lots and lots of people to do that, and they asked 2 questions. Which place do you find more beautiful? And this is very clever, what percentage of people would agree with you? Okay? So I prefer this one to that one, but I might say, well, it's really idiosyncratic, my preference. So I would mark it. I would say only 10% of people would agree with me. Or if I'm confident, I might say 90%. So now they've got 2 values. And by doing some very clever math, they can say this cell, this location, is preferred by 90% of people as being more beautiful, whatever. So the beauty of this approach is that you can get a participant to answer how general their insight is, their label. It's a very smart move. It's a very clever thing to do in surveys. So they ran it for 4 months. They ran UrbanGen for 4 months. 3,300 people participated. 17,000 rounds of annotations. They got a lot of data. And nobody got paid for this. Right? I mean, this is just for fun. This is an interesting example of what's called gamification. So it's a theme you'll see in a lot of places. It's best known by the work of Louis van Aan, who was doing different kinds of comparisons, A/B comparisons. And there's a whole body of work around this, but unfortunately not social computing in the way we're talking about it. But if you're interested in it, I can give you pointers to it. But that's what they did. They gamified the comparison and got a lot of data to be useful. So now they've got all of these nodes in their graph are all labeled. This is 0.9, this is 0.2. So now they can run the standard routing algorithm. Just look that one up. There's a routing algorithm. And this is in London. And you start here on this side of the river, and you say, this is the shortest path. So this is what Google Maps would give you. Right? But if you now say, don't minimize just distance, but minimize distance and beauty, it gives you a different path. Right? See, it's a slightly different path here. If you want to maximize happiness or quiet, those are 3 different paths. Cool. All they can do, basically to do it, is to say, my objective function is distance and beauty, or distance and quiet, or distance and happiness. Ah, very clever. So this is an interesting chart. I will tell you what they're doing here. So this is their testing. So the human validated this, and they asked 30 people who live in London, know all that area in the testing region very, very well. And that said, here, this path, how would you rate this? these people know all of it. So the results are here that if you go on some path, and the Likert scale is a response from 0 to 4, or 1 to 5. 5 is good, 0 is bad. So if you look at the shortest, on quiet, shortest is not good for quiet. It's good for time and so on. But basically, what's interesting about this is that they score pretty well. So this beauty scores are all quite high, okay, even on the shortest path. But for example, the quiet one also scores high. So they achieved their objective. They got what they wanted. Kind of cool, right? Now, the statistician in me has to point out, the paper says these are all significant differences. You know, the distance of these bars is so huge that it makes me very suspicious. They're so big that I would say, as a reviewer, I'd say you have to double that size, that population size, to bring them down a little bit. I want to know the real value. This is too big of a variation in the answers. So. But it's a paper that got published anyway. Okay? So now, remember the flicker thing? What they did in the first part was to ask people in that game to do the A-B comparison. What they did is they wrote a little piece of code that would grab the flicker images of those locations, right? Because a lot of those flicker images, there's like several billion images. They can look up the geocode for that image and say, oh, it's cell 29 in my grid. Pull up a bunch of those. And then you grab the tags with each of those things. And guess what? They ran it through Luke. Remember Luke? It's our sentiment analysis tool. So you can run it through Luke, and it will spit out the sentiment terms, for example, over here. So they end up categorizing it in one of these 6 Luke categories. And they say these are positive or negative, right? It's very clever, because this is a pretty simple thing to do. You crawl for Flickr images that are in the location. You extract the tags, you run it through Luke, and Luke spits out one of these. You know, like it's 0.1 positive emotion, 0.8 negative emotion, 0.5 swearing, and so on, right? And now you can correlate each of these, like the positive thing, with the happy metric, with the happy objective function. This is very smart. I was very impressed with this paper. Because I was thinking that they would write some very clever image analysis algorithm. They didn't, right? This is very clever when you can pull this one off. So this is, ignore these for a second. This is the Flickr beauty route in London from the same place to the same place, right? Okay, so that's, if you look, I thought I actually had it side by side. I must have pulled out the wrong one. Oh yeah, here it is. Here it is. So this is the beauty as in the previous system, the previous algorithm, using the human raters. And this is determining just on the Flickr beauty thing. So there's no humans involved in doing this. This is just the tags plus Luke categorization. They did that, and look how similar those paths are. Minor variations. But I was really impressed by that. I was more impressed by this than by that sort of not quite statistically significant samples of ratings. So this suggests to me, because London is very dense and very busy, and it's full of people and full of things, that it actually worked pretty well. Now, to go back to this, ignore that one for a second. That's the same one we just saw. This is now in Boston. So they did the same trick in Boston. Now, you could argue Boston is a lot like London in many ways. It's, in the United States. But the same, they found that they can get very, very good results with just Flickr. So nobody human rated any of these locations. And yet, again, when you ask people who live in Boston, and I will tell you, I know Boston pretty well, this is a much better path than that one. Yeah, this one will get you there faster. But this takes you right through the middle of Boston Commons. And this is a beautiful, beautiful place to go. Now, if you were going to measure this on danger, you probably wouldn't want to go to that part of town. But they didn't rate that. But they could. Right? You probably couldn't use a Flickr solution for that. But you might be able to, for example, and this is, I think, where this whole work is going. You might be able to correlate it with other data sets, other human-created data sets like numbers of crime incidents by location. So, for example, I assure you there are more crimes committed at that corner than at that corner. Personal crimes or property crimes or something like that. And so now you can imagine having multiple layers of dimensions of objective functions that allow you to take and create a path that goes and minimizes whatever you want. I want to have a beautiful path that's totally safe, right? So that's what I'm alluding to here. They don't have these other measures. So, for example, people don't have measures of crime in this, but you could make one. Same thing for pollution or special events, right? That would be another kind of map you could make. I want to go from this point in Zurich to that point in Zurich, past the places that have the most special events. And you would crawl the special events, say, from a concert calendar or a festival calendar, because there's certain places you want to go, right? Like over by the concert hall or by the stadium on certain days. Or maybe you don't. It depends on what you want. But now there's a way to do that. You can express that way. Yo.
Did they also take into account people by car or by foot, or do they just by foot?
This is all by foot. Yeah. They limited it to that. And as it's a great question because when you're designing a study like this, you have to figure out what to not cover. Okay? And they know that it's a different evaluation function for cars, but getting that data to do this study would be really, really painful. So they show that the idea is valid and works with data that's simple to construct. So that's why they did it that way. So for example, they don't include kayaking. That'd be a major problem, right? Okay, the last paper for today. So I guess I should say that I didn't know any of those folks in the last paper. I think that was the first paper I actually didn't know anybody. But it's a great paper, so I recommended it. So this paper has the intriguing title, Tweets from Justin Bieber's Heart. You might wonder where that comes from. All will be revealed shortly. When this paper was written, Brent Hecht was at Northwestern. He graduated and is now, I forget. He's at a university somewhere in the United States. But Li Chen, Bangwa, and Ed, they were at Xerox PARC, and Ed is now at Google. Bangwa is now at Microsoft Research, and Li Chen is also at Google. But I work with Ed all the time, so he's a good friend of mine. And they did this really nice work. I think at the time Brent was Ed's intern, but it's, I think, a really interesting study. And it sort of is a nice paper to close on for this series of social computing things because it tests the validity of the data. So we just talked about all this Foursquare data, right? Now, I believe the Foursquare data is pretty good, actually, for interesting reason. But what about Twitter data? So the key result here is they found 34% of users did not provide any real location. So if you're doing geolocation with Twitter data, this is the paper you have to read. You want to make sense out of it. So let me show you what I mean. Suppose you go to Facebook and you look at my Facebook profile, right? You can, on your Facebook profile, put in your location. Now this is the location that I live in, but notice it says California, USA, right? It doesn't say, at the moment I'm in Zurich, right? So it's wherever you make your home, right? There's a bunch of other stuff there. It's interesting. I just got a 10-year anniversary Facebook page, but they're early. They're off by a year.
This is Twitter.
Oh, is this my Twitter profile?
Yeah.
Okay, well, the Facebook one looks very similar. You're right, thank you, it is Twitter. That's my Twitter background picture. So You know that in Twitter there's an advanced search page, and you can, for example, say, show me all the tweets, blah, 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 near this place. And you can specify that using a location. You just search for that location. You put in whatever. So here I did one for Zurich, and I did, interestingly, it defaulted to 15 miles, even though I'm in Europe, whatever. And I just did this this morning, and turns out there's a whole bunch. And oddly enough, this was not planned. This is a guy at Google. I actually was sitting not so far from him, so it was very funny to see him show up number one on my Twitter feed. Anyway, so these are now, all the tweets after this are from the centroid of Zurich within a 15-mile radius, so roughly 28 kilometers. Okay? Or you could actually go in and say, I don't want just any generic city location. I want exactly that location, and I want it to be a radius of 1 kilometer. So that's not in the advanced search UI. You actually have to use the API to do that. So I did that too. And the big question is, so what do people do with those location profiles? Now, the reason you might want to do this is because some people actually have the lat long attached to all their Twitter messages. So when I tweet, it actually says like that. That's in Mountain View. It's right next to my office. So that's actual location. So when I tweet, it actually plugs in the current lat long to that. Now, the big question is, how many people have that turned on? Any guesses? What fraction of all Twitterers have their lat long turned on? Okay. It's opt-in. That's a good question, though. Any guesses? You want to guess? 5%? It's a good number. Anybody else?
Their default is it's on.
Yeah. Well, for people who have opted in and turned it on. Okay. That's a good question because we know that if you have a default in, that is default turned on, and you have to opt out, relatively few people opt out of anything. Even organ donation, right? So if your default status for getting your driver's license is it says you will donate an organ upon being found in a crash, few people, like 2%, will opt out. On the other hand, in California, for a long time, this was a great case. A long time it was opt-in, and guess what? 2% of people opted in. Now participation is 98%. All right, so that's a really good question. Okay, so right now this is opt-in, and so from what I just told you, it's like that. It's slightly less than that. So 5% was very generous. Very hopeful or something. Anyway, so the question is, what do people do with their location profiles? This is my random Facebook profile. Here it says where I live and where I was born, where I did my graduate work. And you can look up all those places and figure out where they are. That's easy to do. So the real question is, if we're going to do this analysis, how many people provide it? How accurate is it? Right? I won't make you guess. We're going to work it out. That's what the point of this paper is. Because the reason this is important, and why this is an important paper, is because this, let me read part of this to you. With regard to the Twitter location field, these guys found it in their data set of 76,000 users, 39,000 of them provided information in their location field. Like half. Wow, that's not bad. You should be thinking. But hold that thought. Okay? They applied the Yahoo geocoding API to the location field of those things, and they found this distribution using the timecode offset. They did this. It's fantastic. So this is basically a quote from the paper saying, look, lots of people are using this as real data. We're going to go check it. You know it's going to be something not. They wouldn't have written this paper if that was just all true, right? So here's a Twitter sample of 11,000 tweets I pulled this morning. And my query was to be a tweet that was produced somewhere near Zurich. Okay? And this is a long spreadsheet. It's 11,000 rows. Okay? Now, So here's the date. It's today. Screen name, full name, tweet, the tweet ID, blah, 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 blah. Number of followers, number, so on and so on. But over here on the far right is the location of that person. Okay? So notice I pulled them all from Zurich, right? That's what this says right here. That thing up there. Australia, Zurich. London, Zurich. Bad, Australia, 8800. Does that mean anything to anybody?
Yeah.
What is it, like the postcode?
Yes.
Yeah.
It's extremely tough.
Yeah. Just, does that mean anything to anybody? It didn't mean anything to me. Anyway, you get where this is going, right? So I actually went through these, and in this case, I sorted by the number of followers. So this person, this is the same person, Dr. James Cabot. This goes on for pages, right? And if you look at the time code, this person is tweeting roughly every 4 seconds for hours. That should make you suspicious. This is not a human. This is a bot, right? Anyway, blah, 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 blah. And then you come over here, and it's all from Zug, Switzerland. Great. It's close by. Right? It's close enough. Dr. James Cabot. Actually, if you click, I couldn't resist, so I clicked on a bunch of these. They're all about prints, every single one of them. And what I think it is it's basically a bot that's going through the Wikipedia entries for prints and any mention of prints anywhere in the Twitterverse and retweeting it. Which is why they're coming out every 4 seconds. So what it tells me is that there's a lot of bots in Twitter, which we kind of knew. But it's really something to see that from roughly short period of time this morning, I got roughly 1,000 tweets about prints coming from Zurich. Who knew? So in the paper, though, they got 62 million tweets from that time period, and they estimate they got around 4% of all the tweets. And they got it from this thing called Spritzer, which was an API that Twitter used to support it. They don't anymore. It was primarily for researchers to do exactly this kind of work. So about half of them were in English. They randomly, now this is where the hero's work comes. They randomly selected 10,000 of these for hand verification. Yeah, so we get a room of you guys. And okay, you're going to take 1 through 50. You're going to take 51 through 60, and so on, right? We're going to split it up. I want you to check. Use your best knowledge and try to figure out, are they real? And here's what happens, right? So valid geographic information is about 66%. 18% of it is blank. And 16% of it is non-geographic. 18% of it is just blank. So what is non-geographic information? That's where the title comes from. Because in location, people write things like that, like, I'm in Justin Bieber's heart. You're right. Take it metaphorically, right? But 61 users in that sample set said something about Justin Bieber in their location. I mean, that's an astonishing number. So what do people really put in their location field, right? So roughly 40 some odd percent of people are putting nothing or junk, right? So the junk is a popular reference to in culture, some kind of privacy-oriented thing saying, don't look here, something like that, so on. 4% of them, 4.5% of them are insulting, like you idiot, and worse, right? Anyway, so this is a couple of examples from this morning's Zurich. Can you tell me what this means? Doesn't seem to make much sense to me. It's like, I think it's just kind of random. Anyway, but yeah, I don't. That's actually supposed to be red. I lost the color somewhere. It's like a little red tulip flower. So people do all kinds of stuff with their location thing, and they're not necessarily all that. So let's look at those locations that we can identify. that we believe are real places, right? The scale is interesting here because people, by and large, choose to set their location at the city scale or maybe the state scale. And that's kind of it. They will very, very rarely say anything more discreet, like this building on the University of Zurich campus. Nobody does that, basically. So 64% of users who specify a location say the state. So if you're from Germany, you might say Bavaria, right? Something like that. Of course, interestingly enough, if you do that same thing in India, states in India are really big. Like the state of Uttar Pradesh is roughly, it's like the size of California, but it's got the population of the entire United States in it. You know, it's like 255 million people. I've never visited it. I'm not sure I want to go there. But you see what I mean? States are very different in sizes. So a canton here would be the equivalent of a state, I guess. And so we also discovered this really interesting thing that the Uber Twitter client automatically puts in the lat long, right? So it's a BlackBerry app. Blackberries, remember Blackberries? Yeah. Anyway, there was an app on a BlackBerry that would automatically do that. So in that case, that's not opt-in, opt-out. You don't have a choice. If you use that client, it automatically disclosed your location. Since executives loved BlackBerries, lots of executives were disclosing their location and had no clue, right? And this is really embarrassing when you're going to a client's location and you don't want anybody like the press to know about it. Anyway, so this is one of those things that this is why there are technology people to help executives. Anyway, this is what I was just saying. Lots of people use cities. State is next most common, but it's very, very rarely even at the neighborhood level or at the grain size of your street address. Almost nobody does that. Makes sense. But what does this mean for doing this kind of work? Here's the big result, right? So we know that most people will give you the state, which is kind of coarse grain. But a lot of people put in what they think are cute things, like Middle Earth, Lord of the Rings. Now, remember early on I said that analysis was done by using the Yahoo geocoder, right? And that's how they got to half of all their tweets having locations. Well, when you actually look at the data, Middle Earth returns to the Yahoo geocoder that lat long, which is north of Lubbock, Texas, which is in the middle of godforsaken nowhere, right? But that's where Middle Earth is, I'm just telling you. Or rather, that's what the geocoder will give you in your data, okay? Or Beavertown is in Missouri, and somewhere over the rainbow is in northern Maine. You see the problem here? So, especially when you're working with large data sets, always hand check some, right? Yeah, and wherever your mama is at. Yeah, it's like over there somewhere. So what it's supposed to do, right, is if you give it a description like this, it's supposed to return that. But obviously, it kind of doesn't always work out, right? Yeah.
Do you know how the API came to these results? Did they learn from a lot of people?
That is an excellent question.
Why does it give those results? Because normally you would assume they would use like a gazetteer or something.
You know the word gazetteer?
I have to.
You're a librarian?
No, I have to
Work in
work
maps?
with a project where
Okay.
we geolocate stuff.
Because nobody in the United States knows that word.
No, we use it for,
Yeah.
we're doing like this crowdsourcing project where we geolocate
You should define what gazetteer is.
toponyms. It's actually a list of geographical names.
Yeah. Like Middle Earth.
Yeah.
Well, I mean, real places, not pictures. So the real answer, so that's great. So gazetteer is basically a manual geocode. What probably happened is that I have two ideas, and I don't know which is true. One is that they used a copyrighted gazetteer, And to preserve copyright, what they will often do is they will insert fake places into the list.
You also
Like,
do that on maps.
and they do it on maps too. So you know about this? Everybody know about this? Trick. So if you're a map company, sorry, this is worth 30 seconds. If you're a map company, you put a lot of time and effort. This is pre-Google, right? You put a lot of time and effort into mapping out, say, all of Zurich, every stupid little road, every pathway and all. So you don't want people stealing your data because you put a lot of time and effort into it. So what almost every map maker did is they would put in a fake street, kind of in the middle of nowhere, and they would say something like, so sue me street, right? So sue me, right? It's something made up name. And they know it's not real. So if your map shows up with this and it doesn't have, and you didn't pay me for it, I can say you violated my copyright. So that's the protection copyright thing that a lot of map makers did. And gazetteer publishers did the same thing because it's very hard to make a gazetteer. So they would, and I don't know if that's what happened here, but I'm willing to bet that's one possibility. The other possibility, because I'm sure they wouldn't have done Beavertown, right? But what I think is happening is spell correction is going on. And so they're recognizing this as, I don't know, Beartown, which is something that's a real town. And I'm 99% sure that's what's happening here. It's saying, no, that can't possibly be that. And so it spell corrects that something is in Maine, a real town. Yeah.
So I have a potential solution as well.
Yeah.
At least like with Instagram, you used to be able to write your own geotags.
Yeah.
They've since stopped that.
Yeah.
But basically what would happen is the first person to write a new geotag,
Right.
it would place that tag at wherever they were.
Oh, okay. That's also very likely.
There are now some legacy
Yeah.
ones that did
Yeah.
not delete, so you can still find stuff like that in that place.
Yeah. So that kind of stuff was a huge, huge problem. Because at Google, we had this thing, forgot what it's called. It basically allowed you to add data to the maps, to Google Maps. And we had to discontinue it when somebody added a road that outlined the shape of somebody urinating on the flowers. Really? So we had to discontinue that. But I'm willing to bet you, a franc, that somebody added like Dan Russelltown, Oklahoma or something like that. So they just added stuff like that. And so it makes spurious data. But it brings up a really interesting point, which is anytime you give people the ability to edit data or add data, you will get bad behavior. It's an axiom. It's just true. And it also seems to happen only when the population gets above a certain size. So we first noticed this, and this is kind of a good story to sort of end the whole lecture on. This bad behavior seems to emerge when the group gets to be large enough to be anonymous. And that's roughly 2,000 or 3,000 people. Below that size, if, say, this gentleman in the blue shirt adds something, I'll look at it and go, oh, that's Pedro. Oh, yeah, you're not anonymous, right? You can't hide if the population is small. But once it gets large enough that I don't know who P29 is, people start to act badly. And this is kind of really one of the fundamental things we learned about social computing very early on. And it unfortunately happened at Xerox PARC when I was working there. We built the first, Pavel Curtis built the very first massive role-playing game, online role-playing game called Lambda Mu. And once it got up above a few thousand people, we started seeing bad behavior. People were acting out and doing all kinds of horrible things. I kill you repeatedly. Kill, 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 kill. Right? Like, why are you doing that? Because I hate you. Kill, kill. And so this is one of these aspects of social computing that we had not thought about. And even though it seems obvious now, back in the dawn of time in the mid-90s, it was not obvious that people would either act badly or that they would do spurious place names or any of that sort of unfortunate behavior. At any rate, that's actually an upbeat story because now we know better. Now when we design these social interaction systems, we now know as a culture, the Facebooks, the Amazons, whatever, now know that if you give anybody the ability to make open comments on something, it's going to fill with terrible, spammy stuff. You just can't do it. Okay? We learned that lesson the hard way, right? The YouTube comments are better now, but like 2 years ago, they were terrible. So we learned that we can't do that kind of stuff. Again, that's sort of a negative aspect of social computing, but it's an aspect of social computing. Okay, so we reached the end of that lecture. I'm going to propose we take a 5-minute break, and we'll get you guys set up on this computer. Okay, and I'm going to set up this shared document to comment, and you get to be guinea pigs. I mean, no, you get to be the leaders, the frontiersmen of the class. Okay, so let me get out of this and stop the recording.